So assignment, alcohols and halogen alkane, question number 15. The skeletal formula for cyclohexanol is shown. The actual bond angle differ from the two-dimension diagram. As you can see, we have to find what is a carbon-carbon bond like this. So it means the hydrogens are not given. This is a skeletal formula. So carbon is forming a 4 bond. So when carbon forming 4 bond, when there are 4 bond pair and no lone pair, then what should be the bond angle? As we know, structures are tetrahedral structure with a bond angle of 109.5 degrees. Then what is the angle of COH? So what is the angle of COH? Like the C is there, O is the central. This oxygen will have 2 lone pair. So when 2 lone pair and 2 bond pairs are there, then the structure, it will be a bent structure, bent or a V shape with a bond angle of 100 because each lone pair reduce the angle by 2.5. So by 109 minus 2.5 will make 107. 107 minus 2.5 will make 104.5. So because here all 4 were bond pairs, but here we have 2 out of 4, 2 bond and 2 lone. So each will reduce the angle by 2.5. An explanation is that it contains 2 bond pair and 2 lone pair, and lone pair repulsion is more than the bond pair. That's why the bond angle will be shorter or reduced. Suggests what you would expect to see when cyclohexane react with hexanol react. So whenever alcohol react with any alcohol is there react with sodium metal. So what is the observation? We'll observe fizz and the metal or a solid dissolve and it will form a white solid or a precipitate. That we discussed already, that whenever any alcohol react with sodium. So white PPT you can mention. You can mention temperature rise also, but fizz is the most prominent thing as hydrogen gas is given off or a solid dissolve. Phosphorus 5 chloride, phosphorus pentachloride is used to test the presence of OH. Write an equation for cyclohexanol and phosphorus pentachloride. So cyclohexanol, first we'll count how many carbon atoms are there. So C6, H11 and OH will be there when you count the total. So C6, H11, OH. React with PCl5. So it will give C6 like POCl3 plus H halogen alkane will be there. So it will produce C6H11Cl plus POCl3 plus HCl. And if they ask what is the observation, so because hydrogen halide is there, so we'll observe a misty fumes. And these misty fumes will turn into a dense white smoke if this is exposed to ammonia, because ammonia react with hydrogen halide to give ammonium halides, which is dense white smoke. Write a chemical test you could use to identify the gas produced and the observation. So how we can test, how we can check? We can test with ammonia. And what is the result or observation? Result will be dense white smoke. So misty fumes will turn into a dense white smoke. Cyclohexanol react with hot acidified potassium dichromate. So this is an oxidizing agent, skeletal formula of organic product. So if we have, first we have to check which one halogen, and like example, because oxidation of alcohol, if it's a primary alcohol, it will be first aldehyde and then carboxylic. If it is a secondary, it will be ketone. And if it is tertiary, it cannot be oxidized. So when you check the cyclohexanol, it is the carbon which is attached with OH is having 2 carbon chains. So it means it is a secondary because 2 carbons are attached. So secondary alcohol oxidized to ketone. So ketone, the same structure will be there, but the formation of a ketone means carbon attached with O. So CO will be there. So that's a product of oxidation. And what is the observation? If you use potassium dichromate, so it will turn from orange to green. So original starting color is orange. and the final color is green. The mass spectrum, about the mass spectrum, this is in mechanism topic, so analysis and mechanism. That's the last topic we'll discuss, and then you will be able to answer this. In question 16, which of the following is a secondary alcohol? Butane 1-ol, butane 2-ol. So just to be sure, better you draw the structure. Because when you draw the structure, you can easily identify whether it is primary, secondary, or tertiary. So butane 1-ol, but means 4 carbon, and OH is attached with the first. So it is primary because the carbon which is attached with OH is having 1 carbon chain. Butane 2-ol means 4 carbon atoms are there and OH is attached with the second carbon. So this is a second carbon. So it's having 2 carbon chains, so means this is secondary. That's why B will be the right answer. What about tertiary? Like 2-methyl propane 1-ol. First position OH and second position methyl. So the carbon which is attached with OH is having 1 carbon. Like this whole is 1 carbon chain. So that's also primary. But 2-methyl propane 2-ol, that is tertiary. Like 1, 2, and 3 carbon chains are there. So this one is tertiary, this one is primary, this one is secondary, this is also primary. So we want to select a secondary. That's why option B will be the right one. Then the compound has a systematic name. So what is a systematic name? We always select, like count 1, 2, 3, 4 carbon atoms are there. Select the longest carbon chain. Numbering should start from nearest branch. So 1, 2, 3, 4. So second position, we have a branch. And there are 1, 2, 3, 4 carbons. So it is 2 chloro and 4 carbon butane. So A will be the right answer. So select the longest carbon chain. Numbering should start from a nearest branch. And in question 18, when chloroalkane is heated in aqueous potassium, so aqueous potassium hydroxide or aqueous sodium hydroxide, this will undergo a substitution reaction. So reaction will, and substitution reaction can occur for primary, secondary, or tertiary. The primary and secondary normally undergo SN2 reaction and tertiary will undergo SN1. So no reaction occur with primary, secondary, or tertiary, that's wrong. A reaction will occur with primary, secondary, but not tertiary, that's also wrong. A reaction occur with tertiary, but not with primary, secondary, that's also wrong. So a reaction will occur with all primary, secondary, and tertiary. That's why option D is the right. So reaction will occur, but the mechanism of the reaction is also like nucleophilic, and type of reaction is substitution. But that might be SN1 or SN2 depending on which halogen alkane we have. If we have primary, then it will be SN2, primary or secondary SN2 likely, and tertiary it will be SN1. So these are the questions related to assignment, alcohols and halogen alkane.